All right, in today's lesson, what you're going to do is you are going to look at atomic models. So you're going to look at different ideas that people have had about the atom over time throughout history. Okay, at the end of this lesson, what you're going to work on is you're going to work on completing a timeline to show how the models of the atom have changed over time. And that is your goal for today, to show how the model of the atom has developed over time. In your kind of page here, your modified goal page, what you need to do is you need to put today's date as well as the timeline of atomic theory developments. For the location of evidence, you're going to either put online for Google Drive or in your textbook or in your your notebook, okay? And you need to put a page number as well. The words that you should be writing down and doing definitions for by the end of this lesson include proton, electron, neutron, electron cloud, and nucleus. Now, as we continue, what we're going to do is we're going to do just quick revision of what is an atom. Okay, yesterday we looked at what is an atom, so who can remind me what it is? Hopefully you said that it is the smallest piece of any pure substance. It is indivisible. We cannot make it any smaller. Where did this name come from? Does anyone remember which Greek philosopher it was? Well, it was Democritus. Okay? What we are going to do now is we're going to actually go back to the Greeks' time and look at how they classified matter on Earth. So in the time of Aristotle, around 450 BC, there were 4 elements. Everything on Earth could be classified as either air, fire, water, or earth, depending on their properties. So the properties included dryness, coldness, wetness, and hotness. That meant, for example, fire was a combination of hotness and dryness. Earth was a combination of coldness and dryness. Everything could be fit into these 4 elements. The Greeks were thinkers. They weren't, they didn't have the tools either to really try and understand more than what they could just see themselves. They also did a lot more philosophy, so they did a lot more thinking. Okay? A little bit later on, in the kind of mid-1200s, 1300s, in the Middle Ages, we had a boom in alchemy. Alchemy is the study of kind of elements as well as an idea of magic. Alchemy came from Egypt and the Arabics, and it worked its way to Rome and to Greece. What the alchemists believed is they believed that everything came from one single substance, but it depended on how pure that substance was. So gold was the most pure. It was the most like the original substance. Silver was the next one. And as you got through different metals, the purities changed. You also see the original Greek elements as well of fire, air, water, and earth. The alchemists were very important in developing symbols for the elements. You can think of this as kind of like a modern or an early day periodic table. Now, although the alchemists believed that they could change copper into gold or any other metal into gold, which was the most valuable and the most pure, as well as they were looking for kind of like a potion of immortality, some of their beliefs didn't really hold true, but they did give us kind of that first basic experimentation. Okay? Almost 500 years later, we finally get to the models and theories that we now have today. So this is what we're starting with now with the atomic theories and the atomic models. The first kind of father of the atomic model or of the atom is considered John Dalton. John Dalton was born in England and he lived in the late 1700s. Okay? Dalton came up with an atomic theory. He came up with some rules to explain what atoms were. The first rule defines what an atom is. It is that all matter consists of tiny particles called atoms. Okay, up until this point, we've always been using the word particle. We now are going to switch to using atoms. Atoms cannot be created or destroyed, and they are unchanging. So you cannot divide them smaller and you cannot destroy them. You also can't create them though. So you can only have a certain amount of any substance here on Earth or in the solar system. We now know that that is a little bit different, but for the 1700s and for many, almost the full 200 years after, this has been one of the predominant theories. All atoms of a specific element are identical in mass and property. And a chemical reaction is the rearrangement of atoms. So they are not being destroyed, they're just being rearranged. Okay, when we do our chemical reactions unit after Christmas, this is going to be a very important piece. Lastly, compounds are formed by a combination of two or more different kinds of atoms. So these last 2 points here, when we come back from Christmas, is going to be important. Now, I'd like you to pause the video and write down Dalton's theory. Once you have done that, then you're going to continue on. And I'd actually like you to have a look in Google Classroom at the timeline, okay? So what you're going to do is you are going to be completing a timeline to show how the atom has changed over the years. You need to include the name of the model, okay, which I've actually done for you, who came up with that model, and what they discovered. What was their main discovery? Okay, what was their main discovery and how did their model of the atom change previous models? The first one that you need to do is John Dalton, okay? So the idea here that I have two different substances. The ones in yellow are all particles of one substance, for example, gold. They are all identical in the shape and the size. They are all round. Over here we have a different substance. In this case, let's say iron. Iron has a different size and a different color and different properties than gold. This follows Dalton's idea that all pure substances, all atoms of one pure substance, are identical to each other, but different than the atoms of a different pure substance. John Dalton's model is the billiard ball model. With the billiard ball model, basically, he's looking at a round sphere, and that sphere is solid, okay? A little bit later on, you have J.J. Thomson, who discovered that it actually was not one solid sphere, that there was something called an electron. You have two videos here that you can watch, and in Google Classroom, you are going to find the link to the playlist of all of the videos relating to the atomic theories and atomic models. But also feel free to complete the timeline by using the internet as well as your textbook to find information on how each scientist changed the model of the atom. What did they add? How did they change it? Okay, the other scientists that you are going to need to do include Ernest Rutherford, who discovered the nucleus of the atom, Niels Bohr, who found different energy levels for the electrons, and the modern day theory of the electron cloud. This is from Schrödinger and Heisenberg, and this is the idea that instead of the electrons circulating around the nucleus like planets going around the sun, that actually the electrons are found in a cloud, just in a certain area outside of the nucleus. Okay? That is it for the video lesson. So now what you need to do is you need to go back to Google Classroom. You need to click on the atomic theory or the atomic model timeline, and you need to complete the timeline either in Google Drawings or on Prezi or on a cartolina. That is up to you. In your notebooks as well can work for that. Just make sure that you include the scientist's name, their model, the approximate year, and what are the main important parts. So how did they change the atomic model? And what was their discovery? Okay?